Hi all, let's look at 7.3, homework from 7.3. The difference with 7.2 is basically only that the differential equations become, the recursion relations become more complicated. And in particular, we will have to do more shifts. And sometimes we have to shift down, and that results in the index, the change in where we start our summation. We'll see it in the examples. Okay, so let's dive into it. Number 21. Let me copy it here. There is this 5 plus 2x y double prime minus y prime plus 5 plus x y is equal to 0. We always have homogeneous ones. Okay. And moreover, they tell us what is going on here. That at negative 2, why is this doing this? And y prime at negative 2 is negative 1. Now, as they said, you have to center your power series with center the given initial point. So this tells us that x0 is minus 2. So the initial conditions are given at minus 2. That means that we're looking for a power series centered at minus 2. In other words, what we're looking for is a power series. Why is it? It's my hand that is doing this? I don't know. an x minus minus 2, so x plus 2 to the power n. Okay, and so very quickly we need the derivative. And y double prime is summation n minus 1 an x plus 2 to the power n minus 2. Okay, but there's one other thing that we have to do. That's also very important. It's not just the power series that have to be centered in x plus 2, but to make our calculations, to get the correct recursion relation, we should also write our polynomials such. So we have to write this as, well, 2 times x plus 2 minus 2 plus 5. So remember, the way to do that is you write, so in these two cases, you write x as x plus 2, x plus 2 minus 2. So you write it as a polynomial in x plus 2. And then you plug in. And then you expand or whatever, and you always keep the x plus 2 together. So this would be 2 times x plus 2 minus 4 plus 5. So that is actually 2 times x plus 2 plus 1. And the other one is x plus 5. That is x plus 2 minus 2 plus 5. So that is x plus 2 plus 3. Okay, so we're ready to plug everything in. So we get 2x plus 2 plus 1 times the derivative here, summation n double derivative n x plus 2 to the power n minus 2 minus summation n x plus 2 to the power n minus 1 plus x plus 2 plus 3 times summation an x plus 2 to the n. Okay, and that is to be 0. So that's the result of plugging in. Now we expand. So we get summation 2n n minus 1 an, and the power is now x plus 2 to the power n minus 1. So there will be a shift needed here. So I'm expanding, at the moment I'm expanding these two here, right there. So the next one is summation n minus 1 an x plus 2 to the n minus 2. This also will need to be shifted. Then we have minus summation n x plus 2 to the n minus 1 plus n plus summation, sorry, it's an x here, plus summation an x plus 2 to the power n plus 1. This is where we have this higher power, and this is where we need to shift down, and that is where we have to be careful. Plus summation 3an x plus 2 to the n. That's the only one that we don't need to shift, and that is equal to 0. So let's do all the shifts. The shift that is necessary here, so I'll do the shifts in blue, that is n replacing by n minus 1 to get n plus 1, sorry, n plus 1. Right? What we want to do is to get this equal to n, so we have to add 1 to it, and then if we plug it in, then they will cancel. Okay. So this would give me summation 2 n plus 1 n, right? N plus 1 minus 1 a n. This is getting annoying. Huh? A n plus 1, and now we get the right power, x plus 2 to the power n. We need to shift 2 in here, so here the shift is 2, n replacing by n plus 2, so that will be plus summation n plus 2 n plus 1 a n plus 2 x plus 2 to the power n plus 2 minus 2. That's exactly what we want. Now we need to shift here again n to n plus 1, so that is minus summation n plus 1 a n plus 1 x plus 2 to the power n. Then this shift, this guy needs to be shifted, and that's the shift where we have to do n now replacing by n minus 1. Oh, come on. Okay, and so let's do this here. So here I'm going to write the index to show what happens here, because this, so is this from 0 to infinity, right? So if we do this, this becomes 0 from n minus 1 going from 0 to infinity, a n, so we're replacing n by n minus 1, and then we get x plus 2, n minus 1 plus 1, that is n. Okay, so this is adding to it, right? There's no coefficient. So what this means here, this means that n starts from 1 and not from 0. And we cannot just put 0 there, but that's a term that is missing, right? In the previous cases, in the other shifts, we should also always look at the lower bound technically, but the lower bounds are always giving me that you start from earlier, from -1 or -2 or something, that which we don't have anyway, so that's why we just say forget about it, well, I'll start from 0. So that's why they all start from 0, but this one does not start from 0. Okay, so I'll write it here. This is n equals 1, and then finally we have that one we don't need to shift, luckily, the last one. So what does this now mean? Well, we now, what do you look for? Well, we look for the ones that, the indices that are not present everywhere. And what I mean with that, well, so here the summation starts from n. When I don't write it, it starts from 0. Okay, so perhaps I should write it here. So this is from 0 to infinity, this is from 0 to infinity, this is from 0 to infinity, this is from 0 to infinity. Okay, after ignoring the negative ones, right? Because shifts there would be actually negative ones, but we're ignoring them. So they all start from 0 except for this penultimate term here. And so that means that we have to treat the case n equals 0 separately. So we just look at the ones for n equals 0 that are present, right? So we're looking for this one, this one, this one, and this one when n is 0. Now, if n is 0, there is nothing here. Well, this is 0, okay? If n is 0, we do get something here. So we get 2 times 1 times a 2. That's it, right? Okay, the power, of course, is just 0 power, so don't have x plus 1, x plus 2 there. For there we also have 1, so that is minus a and n was 0, so a1, right? So we put 0 in here, right? The next one, there is no 0, so don't try to do anything here, but here we have 1, so we get plus 3 plus 3a0. Now what is this? Well, of course we know all these things always are 0, right? That's the whole point. These are power series that are actually 0 power series. That means all their coefficients must be 0. So we have here the first recursion, but that tells me what a2 is. So it tells me that 2 times a2 is equal to a1 minus 3 times a0. So let's make a little table here that we keep track of what we have. So a0 and a1. A0 we had, a0 was 2, right? This is a0, right? And this is a1. I hope that I don't have to repeat this all the time. So this is 2 and this is negative 1, right? 2 and negative 1, okay. So that is minus 1 minus 3 times 2. So we see that a2 is more. It gets worse and worse, this thing. Okay, let me get out of this and get into it again, because that sometimes makes the thing better. So we get 2 times a2 is minus 7. So a2 is minus 7 over 2. Let me write it here. a2 is minus 7 over 2. Okay. But now, what happens for the n's that are bigger than 0? Well, then that means from n equal to onwards, n is equal to 1 onwards, then each of these has these terms. So we just can now use the general term. So now we look at the general recursion relation that we get. So that's 2n plus 1 and an plus 1. So I'm just now looking at these coefficients, right? All these plus n plus 2 times n plus 1 an plus 2 minus n plus 1 an plus 1 plus an minus 1 plus 3an, and that again is 0. Now we can group like terms. So for instance, we have these two here, right? These are both an, I mean, group like terms, I mean, the AIs. You're looking at the AIs and gather the terms that of the same, that have the same index, right? Subscript. So we have here 2n plus 1 n and minus n plus 1. So in fact, I can factor out an n plus 1. And then I have here left a 2n, and here just a minus 1, an plus 1. Okay, so that's that one, and that's the only one that there is there. So plus n plus 2, n plus 1. I don't expand these things, it's not really helpful. Plus 3an is equals 0. Now, this is important. So what do we look for now? We look for the highest subscript. And so on the highest index, that is here the n plus 2. And we solve for that one. Because remember, a recursion relation has to say, is a formula that says the value of this, in this, if you think of this A's are sequence, they're from a sequence, right? Of this element in the sequence is given by values of lower elements, elements that come earlier into the sequence. Okay, so that's why we have to take the highest one and write it in terms of the lower ones. That's exactly what the recursion would do. So, so we get n plus 2 times n. Okay, n plus 1, an plus 2, and then the other ones we bring all to the other side. So that is a big minus sign, minus. We have n plus 1, I think it's because I lift my hand. N plus 1, 2n minus 1, an plus 1, plus an. Let's write it now in descending order. It's not necessary, but it gives us a little bit better view of what's going on. Plus an minus 1. Okay. And so we find finally our recursion formula is, we have to still divide by this thing here, right? Is minus, now I get the line that I need, so for once, n plus 1 to n, Jesus, this is getting really annoying, minus 1 an plus 1 plus 3. Okay, guys, this, I don't know what to do here. This is, I cannot write like this, right? This is getting plus 3an plus an minus. Okay, I'm going to restart this app. So sorry, this is going to take a little bit. I have to close the app and open it up again. I hope that this time is better, but I'm kind of doubting it. I think it's getting, I don't know what it is. An minus 1, and that divided by n plus 2 over n plus 1. And so, okay, so then the next question that I said was now calculate up to the fourth one. Or the fifth one, I forget now what I said, but let's do up to 4. So what does that mean? Well, we have already A2, so the next one is A3, which value of n corresponds to that is n equals 1. That's what it should be, right? It should be the next one. We did already n equals 0, so now n equals 1, that gives us A3. And so now we plug in just 1 in this on the right-hand side, and we get minus, and get 2 times 1 times A2. This is n plus 1. This is one of these freak thingies. Plus 3 times A1 plus A0 divided by 3 times 2. Okay, and now we have all the values. A2 was minus 7 halves, so the whole thing is a minus sign is in front here. Let me not make the mistake to write the minus sign in the wrong part. So we get, this is minus, A2 is minus, okay. So we have 2 times minus 7 halves, that is minus 7, plus 3 times A1, A1 is negative 1, so that is minus 3, and then A0 is 2, plus 2, divided by 6, so that is minus 8, no. I have to be very careful with my minus signs. Minus, we have a minus in front of the whole thing. And top I get minus 10 plus 2, that's minus 8, and 6 in the bottom, so that minuses cancel, and I can simplify it to 4/3. So A3 is 4/3, and let's calculate A4. I'm only going to go up to there. So where, of course, A4 comes from n equals 2, okay? So we get A4, so meaning to say I plug n equals 2 in this formula, in this whole formula. Here we get A4, and here we get, let's see what we get. That is minus, and on top we get, we plug in 2. So 3 times 3 times A3 plus 3 times A2 plus A1. So notice that is a recursion relation that links an element in the sequence to the 3 previous ones. Okay, so these recursion relations can be kind of complicated. And so in the bottom we get 4 times 3. Okay, and now we plug everything in. Minus A3 was 4/3, so we get 9 times 4/3 plus 3 times minus 7 halves plus, what was it, minus 1. and in the bottom we have 12. So if we work that out, that is minus, on top we have a 12 minus 21 halves minus 1 over 12. So let's multiply. 12 minus 1 is 11, so I'm going to already simplify this. And now I'll multiply everything top and bottom with 2. So I get 22 minus 21 over 24. Okay, multiply this with 2, this with 2, of course the 2's cancel, and this with 2. Okay, so we see this is minus 1 over 24. Let me double check here that that's the right answer. Okay, and then the next one you could try, but I'm not going to do it now. Okay, all right, that was one of them, and the other one is basically the same, except that we have perhaps a bigger shift here. So the next one I want to do is number 43, right? Yeah, number 43. So number 43, let me pull it up. X, there we go again. X plus 1 y double prime plus 2x squared minus 3x plus 1 y prime plus or minus x minus 4 y. Okay, and that's 0, and then they say at 1 we have this is negative 2, and the derivative at 1 is 3. Okay, and again the initial conditions determine what kind of series we're looking for. We're looking for a series now. So here, oh, come on, we're looking for that x0 is 1. So we're looking for a series of the form y equals summation a n x minus 1, right? It's minus the center to the power n. And then we take the derivative. Y prime is, it's always the same, right? So it's just kind of I don't know why this is doing this. I have never had this problem. I mean, not into this extent that it keeps. I think it has to do with me moving my hand while I'm writing. And it makes it completely illegible. That's the problem. Oh, here's minus 1. I'm going to make mistakes because I get so aggravated for what is doing. Okay, now one other thing. So we have written now the y and derivative and double derivative in terms of x minus 1, but we have to do the same thing for the coefficients. Okay, so the first one, that would be, of course, x minus 1 plus 2. What is this one? So this would be 2 times x plus 1. 2 times x plus 1 minus, always say, every downstroke it keeps doing this to me. Look, I go down and it thinks that I want a line here. Is this a setting that I accidentally activated? Paper view, no, that's not, I don't know. So I'm replacing, okay, so what I'm doing here is I have replaced x by x plus 1 minus 1. Okay, so that's what I'm trying to do here. If this lets me do it, x plus, okay, I'm going to try to write a little bit slower. Perhaps that is, sorry, it's going to go a little bit slower, but I don't want to keep having to do this. Okay, so what is this? That is 2 x plus 1 squared minus 2 times the double product, so that's 4 x plus 1 plus 2. Okay, so I expanded, I did the double product, I multiplied everything with 2 at the same time, minus 3 x plus 1 plus 3 plus 1. Okay, so what is this? Let's gather like terms. X plus 1, x plus 1 squared, sorry, I'll just double check here. I'm sorry, give me a sec here. I have something else. Oh, I'm doing everything in terms of x plus 1. Sorry, it has to be x minus 1. Oh, sorry. Yeah, so distracted by this stupid stylus pen acting up that I'm writing everything in the wrong zone. This is x. I have to write x as in x minus 1 plus 1. Sorry. So let me do 2x squared plus 1, 2. So this is 2x minus 1 plus 1 squared minus 3 times x minus 1 plus 1 plus 1. Okay. And now expand, but keep always the x minus 1s together. So that's 2 times x minus 1 squared minus 4 times x minus 1 plus 2 minus 3 times x minus 1 minus 3 plus 1. And so this becomes 2 times x minus 1 squared minus, oh, this is a plus 1 here. There's a plus 1, right? X minus 1 plus 1. Okay, I'm still stuck on that x plus 1 here. X minus 1 plus 1. Okay, so this is a plus 4x minus 1. Minus 3x minus 1 altogether is an x minus 1, and then 2 minus 3 plus 1, so that is actually 0. So this is what is equal to. Okay. So let's now write everything up. So we have x plus 1. Well, that is x minus 1 plus 2, right? And that we do summation n plus 1 an x minus 1 to the power n minus 2. Okay. Then we have this guy plus 2x minus 1 squared plus x minus 1 times summation n x minus 1 to the power n minus 1. And then we have the last term that was a plus, no, what was that? What do we do? X minus 4. Okay, so that is minus x minus 1 minus 3, right? Again, we have to write as the powers of x minus 1. Okay, and so that times summation an x minus 1 to the power n. Okay, so, and this all is 0. So we expand again. And so the expansion here is with the powers of x minus 1, right? So we get summation n plus 1 an x minus 1 to the power n minus 1 plus summation 2n plus 1 an x minus 1 to the power n minus 2. If I'm writing this low on my board, then my hand is resting outside the screen and doesn't cause this wacky behavior. Okay, so the next one, so I expanded this one, so now I have to do this one here. That is summation 2n and the power I'm getting is n plus 1. Okay, so this is one of the higher ones here. We said this is going to happen, right? Plus the next expansion is summation n a n x minus 1 to the n. That's a nice one. And then finally you have to do the third one here. That is a minus summation a n x minus 1 to the power n plus 1. Okay, that's another n plus 1. Minus summation 3a_n x minus 1 to the power n. And this is equal to 0. So, okay, we need the shifts to write everything in the right power. So the shift here is n, replace that by n plus 1. So we get summation n plus 1 times n over a_n plus 1 x minus 1 to the power n plus 1 minus 1, so n, plus the shift that we need to do here is we have to shift up 2, so that is summation 2n plus 2 n. Wait, how come there an n? No, that's something wrong here. This is a plus 1, it should have been a minus 1. They always go down here, right? So this n plus 1 here, this n plus 1 here, I copied this wrong here. This is a negative sign because it was one of these, was so focused on this thing. So this is a negative sign here, and here too because I already expanded. So this is a negative. Oh, okay. So what is this now? Okay, I did it here correctly, yeah. And then here, this would be n plus 1, then, right? Yeah. They have to go down, right? Because they come from taking derivatives twice. Yes, okay. So then keep going now. A_n plus 2. We're shifting 2 up, right? And then we have x minus 1 to the power n plus 2 minus 2, okay? Plus summation. What do we do here? Well, here we have to shift down. So I'll do perhaps the shift down in orange. So this is n goes to n minus 1. So we have to take care here that n minus 1 is now going to be from 0 to infinity. Okay, and then we get, which one is it I've been doing here? Yeah, 2 n minus 1 a_n minus 1 x minus 1 to the power n minus 1 plus 1 n. Okay. The next one we don't have to shift at all. That's cool. A_n x minus 1 to the power n. What about this one? Oh, again, we need to shift down. So this is the same one here, same shift down. So this will give me summation n minus 1 going from 0 to infinity. That's when you shift down, you have to adjust your endpoints. That's the point. So minus a_n x minus 1 n plus 1 n minus 1 plus 1, so n minus summation 3a_n x minus 1 to the power n. That is there. So we see that we have 2, that's where n starts from 1. I'm going to again replace this here. So this is n starting from 1, and here the same, n starting from 1. So when we have a situation like this, and this is typical for 7.3, we have to separate first the ones that are not in common, that not all summations have that in common, that is n equals 0 in this case. It could be more, right? It could be 0 and 1. I think we did an example in the lecture. Okay, so n equals 0. Now we have to plug in n equals 0 in everything, except for the 2 summations that are special. Okay, the ones that start from 1, there's no 0. Okay, so I'll plug this in. Now this is 0 because of the n. So this one is the first one that we get here. We get 2 times 2 times 1a2. Okay. The next sum is the one that starts with 1, so it cannot do. The next one has an n in there. If I plug in 0, it's all gone. That one again has an n, and so the only time that remains is the very last one, that is minus 3a0. And this is equal to 0. So I see that 4a2 is equal to 3 times a0, and a0 was equal to, where was a0? So a0 was negative 2, and a1 was, so I'm making the table again. A0 was -2 and A1 was 3. Did I say it right? Yeah, okay. So this is -6, so I see that A2 is -6/4, that is -3/2. I'm checking here that I have the right answer. This is number 43. No, why do I have a minus? Oh, I plug it in. Wait, I should not have a minus, I should have a... Sorry, let me quickly see here. Yeah, why do I have a -3? Oh, I see here. That's yeah, they have to be very careful here. This is in this expansion here is this expansion that I made a mistake here. So you have to be so careful, and that doesn't work well if your pen is acting up. So here this minus, okay, this is the minus here, but this is minus, so this actually becomes a plus. So this actually had to be a plus here. So this had to be a plus. So it's so easy to make mistakes here. So this was a plus. So this becomes a minus. So this is a plus. This is a plus. This is a plus. So 3/2. Okay. Now comes the real thing, because that's just a special case. But now comes the recursion relation for all n bigger than 0. That would be, so we now have all these coefficients that we have to take, n plus 1, n, a n plus 1, that's this one. Then we have plus 2, n plus 2, n plus 1, a n plus 2. We have this one, plus 2, n minus 1, a n minus 1, plus n a n, minus a n, plus 3 a n. Okay, so what do we have? No, there's something, I copied something wrong here. I see here, wait, there's a copy error here, right? In this shift, I should have an n minus 1 here. Did I do that? No, I did see. I forgot to do the shift here. Yeah, there were too many ANs that I realized that there was a mistake here. I'm sorry. This is an minus 1, so this is the, which one? This one here. Right? Yeah, that's that one. Okay, so we can combine these two here. So yeah. Okay, let me write it over. I hate to copy things because that's when things go wrong, but okay, let me do it. So now combining these two, this is 2n minus 2 and minus n. So that is 2n minus 3 an minus 1. And I also can combine these two, that is plus n plus 3 an. And this is all 0. 0. Okay, so what are we looking for? We're looking for the highest index, n plus 2 in this case. And so we solve for that one. So we get 2 n plus 2, n plus 1, a n plus 2, and then we bring all the other guys to the other side. So minus, we have n plus 1, n, a n plus 1. Is that correct? Yeah, okay. Now I'm starting out everything. Plus, let's write it in descending order of the indices. So this one plus 2n minus 3 an minus 1. Okay, so we solve now by dividing by 2n plus 2 times n plus 1. So an plus 2 is equal to minus, and on top we have n plus 1 times, and do not expand these things, just leave them as they are, because expanding doesn't help anything here. And in the bottom we get 2 n plus 2 n plus 1. Okay, double checking, is this now what it is? Yep, okay. All right, so this is what I want, definitely need, okay? This is the main recursion relation. That is where everything now comes from this. And so now let's calculate a few more terms, right? We did already A2, so the next one would be A3, which we get from n equals 1 in this formula. So this is A3 is equal to minus, so what we have if I plug in 1? I get 2 times 1 times A2 plus 4 times A1 plus 2 minus 3 minus A0 over 2 times 3 times 2. Okay, so A2 was minus 3 halves, so this would be minus 2 times minus 3 halves, that is minus 3. A1 was 3, so that is 4 times 3, that's 12. And A0 was minus 2, so that is plus 2. And that is divided by 12. So we get minus 11 twelfths. No. And again, I got... Oh, no. Where do I get the minus 3 from? No, A2 was positive 3 halves. I copied it here, positive 3 halves. I didn't adjust it there, right, okay. So this was positive 3, so this was, sorry, 70 minus, there's a minus sign on the whole thing. Let me erase this. So I get minus, on top we have 17, and in the bottom we have 12. Minus 17 twelfths. Okay, that's A3. And then let's do one more. So what is A4? Well, that we get from n equals 2. Okay, so A4 is equal to minus n equals 2. Not n equals 4, right? So some people think, oh, the index is 4, so I have to plug in 4. No, because this is n plus 2. And that's why we need n to be 2 to get 4. Okay, so don't make that mistake. That is 3 times 2 times A3 plus 5 times A2 plus 4 minus 1 is 1 times A1 over 2 times 4 times 3. Okay, so that is minus, and then on top we have 6 times A3 was minus 7 twelfths, minus 17 over 12, plus 5 times A2, and that was 3 halves, plus 5 times 3 halves, plus A1, and A1 was 3, plus 3, and that is over 12, 24. That is 6 with the minus 12 cancel, and it gets a 2. So let's multiply top and bottom with 2. We get minus 17, the 2 and the denominator cancel. Here we get 15, 5 times 3 is 15, and the 2 cancel, plus 6 over 48. Top and bottom are multiplied with 2. So this is equal to minus, we get 4 over 48, so minus 1 over 12. Okay, give me a sec to double check. Yeah, minus 1 over 12. And then you can do A5 as well, but let me not do this. Okay, so you see, it is a matter of being very, very careful with your indices. It's so easy to make a mistake there. These are minor mistakes, but there are certain things that you have to be very careful about. I consider a major mistake, for instance, to calculate A4 to plug in 4. That is a major mistake because you don't understand what the formula is. That's different than a copying error. Okay, okay. So that's it. I know it's quite a lot of work, a problem like this, but okay, that's what you get in a high level math course.